In this video, we're going to continue our discussion on solving systems of nonlinear equations in two variables. There's just so many different possibilities for these. I wanted to make sure and walk through enough examples. This one is probably going to be easiest to do substitution. If we start with that first equation, we can easily solve it for x or y. I'm going to solve it for y by dividing both sides by x. And so we have y equals 4 over x. And then we can substitute that for y in the other equation. We had y squared in the equation, so that fraction is just going to be squared, which means we're going to square the numerator and we're going to square the denominator. So we've accomplished step one, which is get it down to just one variable, because that's a lot easier to work with. Now that we just have x, we want to solve for x. And we can't solve for x if it's in the denominator, so we want to work on that first. If we multiply both sides by x squared, that will eliminate the denominator from the second term. So for the first term, when we distribute that x squared into the left side, for the first term we're going to have x to the fourth. And then when we multiply it by the second term, the x squared is going to divide out with the x squared in the denominator, and we'll just have 16. And then on the right side we have 17x squared. And then let's subtract the 17x squared from both sides. There's no term on the left side that has an x squared, so we can't combine it with any of those terms. But what we have now is we have a fourth degree polynomial, and it's one of those that resembles a quadratic. We've solved these previously by doing a substitution. So if we let u equal, let me do this over here actually. If we let u equal x squared, then if we square u, we're squaring x squared, and 2 times 2 is 4. So we can replace x to the fourth with u squared, and we can replace x squared with u. And then we can solve this equation for u by either factoring or using the quadratic formula. This factors as u minus 16 times u minus 1. And so then we have u equals 16 or u equals 1. But we were trying to solve for x, so now we need to use the fact that u is equal to x squared and replace that back. And now just be careful. Remember that there's two numbers you can square to get 16. And there's two numbers you can square to get 1. So we actually end up with 4 different x values here. 4, negative 4, 1, and negative 1. So for each of those we need to find the corresponding y value because remember the solutions are points where these two graphs intersect. So it looks like there's going to be 4 different points here. So I'm just going to break it down like this just so we can keep it straight. So there's our 4 different x values. We're going to substitute them into I'm going to use this equation right here, y equals 4 over x, because then it's already solved for y. So if we substitute 4 for x there, then we get a y value of 1. So our first solution that we found is the point 4, 1, because when x is 4, y is 1. All right, and then we're going to substitute negative 4 for x in that equation, y equals 4 over x. And so we have the point negative 4, negative 1. It's another solution. All right, and then we'll substitute 1 for x. It's 4 over 1, which is 4. So we have the point 1, 4. And then we'll substitute negative 1 for x, which gives us negative 4. So negative 1, negative 4 is the fourth solution. Just to give you an illustration of what this looks like, the second equation was a circle centered at the origin. And the y equals 4 over x is a rational function. That's actually just a transformation of 1 over x. It's been multiplied by 4, so it's just been stretched vertically a little bit. But it approaches the axes as asymptotes still. And so there's our 4 points of intersection that we just found. All right, we'll look at another example here. This time, we've got an x squared and a y squared in both equations. This one's set up really nicely to do addition. If we just added straight down, y squared plus negative y squared is 0, and we'd have the y's eliminated. So I'm going to do it that way. If you did substitution here, you would, you could solve it for x squared, for example, and replace x squared in the other equation. That would be another way to go. But addition works as well. So I'm going to add x squared plus x squared is 2x squared. Y squared plus negative y squared is 0. And then 25 plus 7 is 32. And then we can solve for x by dividing by 2 and carefully taking the square root of both sides, because there's 2 numbers we can square to get 16. So we get 2 x values this time, 4 and negative 4. And so we're going to take each of those x values and substitute it into one of the equations. It doesn't matter which one. I'm going to use the first one because at least the y squared term is positive. So I think that'll make it a little bit easier. So 4 squared plus y squared equals 25. And so we get y squared is 9, and again, be careful there. There's 2 numbers we can square to get 9. So when x is 4, y can be 3 or negative 3. So already we have 2 solution points there. We have 4, 3, and we have 4, negative 3. And then we still need to substitute negative 4 for x as well. The x value is being squared in the equation, so we need parentheses because we're doing negative 4 times itself there. And so since it's a negative times a negative, we get positive 16. And once again, we end up with y squared is 9. So the y values here are 3 and negative 3 as well, but we're finding 2 new points because remember we used a different x value. So when x is negative 4, y can be 3 or -3. So we have 4 solution points for this one. The first equation is a circle centered at the origin. The second equation has subtraction there. This is a hyperbola, which is something that we're going to be learning how to graph in the future. But a hyperbola has 2 branches, and this one looks something like this. And so that's why we get those 4 intersection points there. This one is another good candidate for addition because everything's squared. So we could eliminate the x squared or the y squared terms here. I'm going to multiply the second equation by -2 because then I'll have a positive 2y squared, which will add to 0 with the y squared term in the first equation. But if you wanted to multiply each equation by something and eliminate the x's, that would be fine too. I'm keeping the first equation the same, and then in the second equation multiplying every term on both sides by -2. So that's going to be -4x squared plus 2y squared equals +4. And then when we add, we'll have -x squared plus 0 equals -1. Divide both sides by -1, and we have x squared equals 1, which has 2 solutions, 1 and -1. So once again, just be careful with your bookkeeping. We have 2 separate x values we're working with here. If we substitute +1 into, it doesn't matter which equation we use, I'm going to use the first one. So it was 3x squared minus 2y squared equals -5. And so we'll subtract 3. Divide by -2, and we have y squared equals 4. So y is plus or minus 2. I'm going to squeeze my solutions in over here. So we plugged in 1 for x and we got 2, and also from plugging 1 in for x we got -2. So we have 2 solutions so far. And then we need to substitute -1 for x as well. And x was being squared, so we're multiplying -1 times itself, which gives us a positive. And so this is actually now going to give us the same equation, so the same y values that we had before. But still 2 additional solutions because we used a different x value. So we had 4 solutions for that one as well. Both of these equations have an x squared and a y squared, but since they have subtraction there, these are both hyperbolas. So we'll just sketch a graph over here. So each of these represents a hyperbola. We've got that subtraction in front of the y term. So one of them, they're both going to look something like this. They just have like a slightly different shape. So one of them's essentially skinnier than the other. This is a very rough sketch. But now you can see our 4 points of intersection there. All right, we're going to do one more example here. This one, again, you can do substitution or addition. If you're substituting, I would recommend solving one of these for x squared and substituting it for x squared in the other equation. I would not solve this second one for y because you're going to have y equals 13 minus x squared, and then you would substitute that into the y, which is being squared, and you'll get some fourth degree stuff, which may be difficult to solve. Maybe not. I don't know. I didn't do it that way. Um, but sometimes I have seen students get to a fourth degree and then they're kind of stuck. Or it might just take a lot longer to solve. So if you do substitution, you could solve one for x squared and replace x squared in the other equation. That'd be fine. I'm going to do addition though. I'm going to multiply the second one by -1 so I can just add straight down. So negative x squared minus y equals -13. Here's the other reason I wanted to illustrate this with addition. So my x squareds add to 0. Be careful with this. You can't combine the y terms here. One's squared and one's not. But you can still say I'm left with y squared minus y. You just can't combine them. So just be careful of that. And then on the right side we have 12. So this is a quadratic. I'm going to set it equal to 0 by subtracting 12. And you could factor or use quadratic formula here. It factors as y minus 4 times y plus 3. So the y values are 4 and -3. And so we need to substitute those into one of the equations and solve for x. I'm going to use the second one because then I don't have to square the y. So x squared plus y equals 13. Subtracting 4 gives us x squared equals 9, which has two solutions, 3 and -3. So x is 3 when y is 4, and x is -3 when y is 4. So two solutions from that y value. And then here, if we substitute -3 for y in the second equation, we'll have x squared minus 3 equals 13. Add 3, and we've got x squared equals 16, which has two solutions, 4 and -4. So we have 4, -3, and -4, -3. -3 was our y value, and we got 4 and -4 for the x values. So four solutions again. In this case, the top one is a circle. Both x and y are being squared, and there's addition. The second one, the y was to the first, so that's just a parabola. And when I graphed it, it looked something like this. So circle and a parabola, and there's our 4 points of intersection that we just found.